Today you will be learning lesson 3.3 on solving multiplication and division inequalities. Okay. The way we do this is the same way we did multiplication and division equations. Use your inverse operations to isolate the variable. Okay. However, the difference is if the number with the variable is negative, you need to flip the inequality symbol. Remember, a negative is an opposite, so we're making the answer the opposite of what it originally would have been. Hence, we need to flip that sign to the opposite direction. Okay? So if P is less than Q, okay, and R is greater than 0, which means R is positive, okay, then our values remain the same. Okay, if P is less than Q and we're multiplying both sides by a positive number, our answer is still less than. Okay, but if I have a problem where G is less than H, and then we're going to do something to it by K, and this K is negative, okay, that means it becomes the opposite of what it originally was. So if G was less than, now whatever's happening to G becomes greater than the H and what's happening to H. In this case, division. But no matter which operation, multiplication or division, when you do that to one side of an equation, that sign becomes its opposite. Okay? So if I have 6 is greater than 4, okay? Right here on both sides of that inequality, we are dividing it by 2, right? So that symbol is going to stay the same. It's not going to change, which when we solve this then, dividing both sides by 2, we get 3 is greater than 2. See how that sign remained the same. It started as greater than, it ended as greater than, because that division was by a positive number. Okay? The number 6 up there. 2 is less than or equal to 3. What they're doing to both sides of this inequality is multiplying by 5. Okay? And when I do that, that 5 is positive, so nothing is changing. So it remains less than or equal to. And when I solve that, 3 times 5 is 15, which tells me 10 is still less than or equal to 15. That sign remains the same because that change was positive. The third one, number 7, okay, we started with negative 12 is less than negative 9. What they're doing to both sides is dividing by a positive 3. Okay, so when I do this, negative 12 divided by a positive 3 is negative 4. Okay? My original symbol was less than. Down here we get less than. And the reason it didn't change was because this 3 was positive. Positive thing on both sides, positive multiplication or division, the sign stays the same. Whereas when we look at these bottom 3, number 9, it was 6 is greater than 4. When I change that inequality by dividing both sides by negative 2, still getting that equivalent inequality, I get negative 3 and negative 2. Now negative 3 is less than negative 2. So what happened was, since I changed this by the opposite of 2, my sign becomes the opposite of what it originally was. Okay? So I started with 2 is less than or equal to 3. I'm multiplying both sides this time by a negative 5. Okay? When I solve that, 2 times negative 5 is negative 10. 3 times negative 5 is negative 15. This time, negative 10 is greater than negative 15, and it was or equal to before, so it still remains or equal to, okay? But it's flipped directions because we are multiplying it by the opposite of 5. That negative 5 makes that sign switch directions. And the number 11, okay? It started with negative 12, or is less than negative 9. They're dividing both sides by a negative 3. Okay? Since that number was negative, what happens is that sign is going to switch. So this was originally less than, it's going to become greater than. okay? Because when I take negative divided by negative, it becomes a positive, and 12 divided by 3 is 4. Negative divided by negative is again a positive, and 9 divided by 3 is 3. So if we look here, 4 is greater than 3. That symbol switched because whatever we did on both sides was either multiplying or dividing by a negative. Okay? Multiplying or dividing by a negative makes the sign become its opposite. Okay? So let's solve some inequalities. Okay? These solutions you can still graph just like we did yesterday on the addition and subtraction, but today I'm just focusing on your answer. Okay? You can still graph your solutions if it says so. Okay? So if I want to get x by itself, right now what's happening to x is they're multiplying it by a negative 5. So to isolate it, I need to divide both sides by a negative 5. Okay? And again, since that change, since that division is by a negative number, our sign is going to get flipped around. So we have x left over here on the left, but now instead of greater than, it becomes less than because we're changing it to its opposite, right? And negative 10 divided by negative 5 is 2. So x is less than 2 is our solution, right? This one is written kind of funny, but remember when there's a negative out front, that negative either goes with your numerator, or in this case, we can write it with our denominator. Since it's a positive divided by a negative would give me that negative answer. So I'm going to change this problem to look like this. Right? It's less than negative 1. Okay, because here if this is positive, it's going to become a negative answer when I divide it by a negative. If I were to plug in a negative number right here, they would cancel. Negative and a negative becomes a positive. Same thing here. A negative divided by a negative would become a positive. So if you end up with a number and it has a negative sign out front of it, you can move that so it's with your denominator. Okay? So in order to solve this, I need to multiply both sides of my inequality by negative 3. I was originally dividing by negative 3. Okay? So this side's canceled. Since my division was by a negative number, okay, my sign is going to change. So it was less than, but now n becomes greater than. Change because of that negative. And negative 1 times negative 3 becomes a positive 3. So the solution to this inequality is n is greater than 3. Same thing is true for decimals. Okay, if I want to isolate x in this problem on the left, right now I'm dividing by 4.2. The way to undo that is to multiply both sides by 4.2. So I'm multiplying both sides of that problem by 4.2. Okay, what happens is that original 4.2 on the left side cancels out, and I'm left with x. And what I did was I multiplied both sides by a positive number. Okay? This 20.45 is negative, but what I multiplied by over here, this number is positive. What I did on both sides was positive. So in this problem, my symbol is going to stay less than. Okay? Even though there's a negative in the problem, it's not by the change I do on both sides. Okay? So when I take 4.2 times a negative 20.45, I get a negative 85.89. Okay? It started as a decimal, so I want my answer to remain as a decimal. Okay? The next one is my variable term. Right now x is being multiplied by a negative 5.3. So to undo that, I need to divide both sides by a negative 5.3. Whatever I do to one side, I still do to the other. Okay? Negative 5.3. Okay? And when I do that, these 5.3's cancel, and I'm left with x. This time, what I'm changing it by on both sides, my work, is negative, so my sign is no longer going to become greater than, it's going to become less than. So x is less than, and when you divide 21.2, divide by negative 5.3, you end up with x is less than a negative 4. Okay? Again, that symbol changed in the second problem because what I changed on both sides was negative, remained the same in the first problem because my multiplication on both sides was positive. Okay. Same thing true for fraction problems. My steps again don't change. My goal is to isolate the variable. Okay? So when I look at this first problem, right now c is being divided by 8. To undo that, I multiply both sides by 8. Okay, the 8's cancel. This time my change on both sides, this 8 right here is positive, so my sign's going to stay the same. So c was greater than, it remains greater than, and 1/4 times 8 is 2. So c was greater than 2. Okay? Alright. Same thing's true over here. If it's a mixed number, my steps do not change. Okay? My goal is to get x by itself. Right now x is being multiplied by 2 2/3 to make it easier. Or to get x by itself, I'm going to divide both sides by 2 2/3. Whatever I do to one side, I do to the other. Okay? This 2 2/3 on the left cancels. Okay? And if I'm wondering about my sign, this 2 2/3 is positive, so my sign again is going to remain the same. Okay, so x still going to remain less than. My answer is going to be negative and 5 1/2 divided by 2, 5 1/2. Divided by 2 2/3. Becomes a negative 2 1/16. Okay. Negative 5 1/2 divided by 2 2/3. Okay, symbol again stayed the same because what I multiplied on both sides was a positive. Okay. So let's look at this problem right here. Okay? Describe and correct the error in the solution. Okay, if I'm looking at the original problem, this one has that negative out front, so negative n over 5 is greater than 2. Okay? What they did on both sides, again, just like I did, but they didn't show that step, is they moved that negative to that denominator. Okay, it goes with that bottom of that fraction. So they multiplied both sides by a negative 5, and since that number is negative, they needed to do the flip on their sign. Okay, and that's what they forgot. Okay, so when they described the error, they forgot to flip their sign, or the inequality symbol would be the proper wording. Okay, and that needs to be switched because they multiplied by a negative. Okay, or since they multiplied both sides by negative 5. Okay, so that's the error. To correct it, okay, when I do that, the only thing that needs to change is n instead of greater than, had to switch to less than negative 10. So here's my description, here's my correction. A word problem. Okay. A student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most $50 for this project. What are the possible number of cases the club can buy? Okay. I'm going to use that marking the text strategy. Okay. The club can spend at most $50. Okay. That's the most they can spend, so that's my total. And at most means they can spend less than or equal to that amount. Okay, so my answer has to be less than or equal to 50. And I know that each case of vegetables, okay, a case, costs $10.68. And if I'm buying more than one of them, that's a multiplication problem. So on this side, we have 10.68 times our number of cases. So n in this case is representing the number of cases. Okay, defining that variable. Okay, so in order to get n by itself, I need to divide both sides by 10.68. Whatever I do on one side, I again need to do on the other. Those properties of equality, or in this case, properties of inequality. So 50 divided by 10.68 gives me an answer of n is less than or equal to 4.68, and it goes on and on and on and on and on, okay? But if I'm thinking about this in a word problem, I cannot buy a partial number of cases, so the possible number they can buy is 1, 2, 3, or 4 cases. Okay, I can't quite afford the 5th one, so that's the most they can buy. Or I could say, at most, 4 cases. Or another thing I could have said was 4 or less cases. Okay, any of those answers would be a possible solution. Okay. So the trick for today is when you are solving linear inequalities with multiplication or division, if you multiply or divide both sides by a negative number, you need to flip your inequality symbol. Okay? And as a quick reminder, if you are graphing linear inequalities, if it's not or equal to, it's an open circle. If it is or equal to, it is a closed circle.